Charlotte, North Carolina, southeastlinuxfest.org. Otherwise, I will let Ben Francis, protocol junkie and security nut, take it away.
All right. I am Ben Francis, and I'm going to be presenting Web 3.0. That is my term for a recent revolution in web technology that I just learned about 3 weeks ago. This is the guy to blame. Can you all see that? The blame this guy slide?
We can see current slide and next slide.
Oh, you can? Okay. Let me... How'd they change this? All right. Hold on. Ugh. All right. I just start from first slide. Okay. Here we go. Oh, you dirty dogs. LibreOffice has switched. Okay, see, you guys are seeing the right stuff, and then everybody else is seeing this.
Actually, it's grayed out now.
It's grayed out. Awesome.
I can see both slides, but they're gray.
Well, the time stopped incorrect.
What was that, Mara?
It's frozen.
Yeah, it's unfroze because the time's not ticking off.
You're in presentation mode. It detects the.
Okay, apparently I'm sharing my screen instead of the.
So try to.
All right, hold on.
You know, like show both at the same time.
Yeah. All right. Here we go.
There's your face.
All right, hold on. I'll get you. Which one? F5. Okay. It's doing the same thing. Hold on.
That's what they see. So.
Okay. All right. There we go. We got that. Full screen. Full screen. Are you kidding me? Okay. All right. We'll just have to keep trucking like this. Because I don't know how to fix it. I mean, shoot. Okay, so Web 3.0. And if I was going to ask if anyone knows this guy, but the next slide clearly shows it. So this is Marcus Raynham, and in 2000. Near the end of 2009, he gave a great talk on at TEDx Mid-Atlantic called Internet Nails, and he described why the internet was so broken. He made a pile of money in the 1990s coding firewalls, and the reason he was able to make that pile of money is because of the way HTTP was designed, and HTTP was designed the way it was, which was stateless, because Tim Berners-Lee in 1989 had to make a deal with the devil as far as HTTP and TCP was concerned. TCP gave him. Are you hearing? Are you hearing me?
I can hear you. I only see Web 3.0, the title page.
It never refreshed. Okay, hold on. I think I got. All right. I think I got two windows open. That's what I did.
Yeah. Why don't you do the presentation?
All right, here. Hold on. I got two windows open. Close one window. All right, and Function F5. Again. What?
No, I was saying, why don't you do the presentation on that?
Yeah.
And it's what you see, and then I can play for us here.
Okay.
And then, you know, I mean, that might work better.
Okay. What?
See what I'm just, I'll plug in mine,
Okay.
and then you just share your screen and do
Okay.
that thing there.
All right. Can you see the next slide now? Blame this guy.
No.
Yeah.
Stop sharing. All right, hold on. Application window. There we go. Oh, unbelievable. Can you all hear me?
Yeah, I can hear you.
Yeah, you're going
I
through.
can't hear you all at all. I swear to God. All right, I think
So that's literally what you're sharing.
I gotta quit Firefox. That's what it is. Stop sharing. All right. Now, application window. Oh man, I hate this.
We can live with this.
Your laptop might be thinking it's still sharing. What I'm saying.
Oh, great.
Okay. Slideshow settings. Yeah, okay. Now, F5. Okay, I think I got it. Now I can't hear anybody. Hold on. Switch over.
Can you hear me now?
Yeah, I got you now. And application window.
I mean, you might want to turn your volume up on here because, you know, this sound comes to
Yeah. Okay. Can you all hear me?
Affirmative.
Okay. All right.
Loud
Good.
and clear.
And it doesn't look like you're seeing the presentation yet.
I'm seeing your
Just the icon.
It just went away.
Ugh. Come on now. All right. Let me try it again. Share.
Now it's back.
You got my Web 3.0 window?
Yeah, I can see Web 2.0,
Okay.
the title page.
All right, good. And now you got the full screen?
No.
But that's okay.
Hold on.
Don't have full screen, but what you got perfectly usable. By the way, I find a nice bit of levity added by the giant smile over your shoulder, Ben, as you're having trouble.
Alice in Wonderland. Oh, awesome. All right. Why isn't it? So you can all see the Web 3.0 presentation?
Yes, we see your
All right.
slide.
You see the second slide, blame this guy.
Yeah, I can see PowerPoint.
Can you see the blame this guy slide now?
No.
No, it didn't change.
It's editing. It's in the edit slide mode.
Edit slide mode.
Blame this guy.
I'll help you out, Ben. I will show you exactly what you're broadcasting.
I got another guy here with a computer here that's showing me what's happening, and I just see grayness now. But you guys can see the blame this guy slide.
Affirmative.
Okay. All right. Well, I'm just gonna keep on. I'm gonna keep on trucking. Sometimes Jitsi has trouble with full screen presentations. So, all right. Yeah. 2009. Marcus Rainham gave a presentation called Internet Nails. And Internet Nails. Everybody should just stop the presentation right now and just go watch that because it is awesome. It correctly defines the problem as HTTP inheriting state from TCP and then throwing it away. And the reason that Tim Berners-Lee did that is because there were only 12 sockets in the partial socket table in BSD at the time. And everybody was using Bill Joy's TCP/IP stack that he had written in 1976, and even Microsoft was. They just didn't admit to it. So when Tim was working with HTTP, he said, okay, if somebody has an index.html file and pulls it down with 5 GIFs, that's going to take up half of the partial sockets. If 2 people did that at the same time, it would fill up all the sockets. And then if one more person got on the box at the same time and started a 13th connection, it would crash the box. And TBL was smart enough not to allow that. So he said, well, I got to make HTTP stateless. And that's it. So, and his talk was called Internet Nails because it followed the old story of for want of a nail, a kingdom was lost. And this is that nail. And I first saw this about 7 years ago, and it really set the alarm off in my head about all the security problems that we're having in the internet, and I started looking for solutions. And I didn't really find any until about 3 weeks ago when I ran into let me just tell the problem with HTTP. The problem is the basic problem with HTTP is stateless. It works great as Web 1.0, which was just a document retrieval system. But as soon as we switched from that to Web 2.0, which was web applications over the internet, everything's gone kaflooey. And it's because we're having the managed state at the wrong layer. HTTP rests on top of TCP. TCP if you're a network guy, you know about the networks. You know, there's 7 layers in the network cake, and TCP is right at layer 4. HTTP is at layer 7, right on top of the stack. And because it is, web application programmers had to invent a way to maintain state at the application layer. So that's when they came up with cookies in 1995, 1996, and that allowed companies like Amazon to be able to track you from all the connections that you were making to the server. HTTP throws away the state it inherits from TCP. Again, this is because of the way TBL had to design it. The state has to be created by the application. The state does cookies on the client and sessions in the server. Whoops, sorry. And therefore, the applications have to manage the state. So here's the problem. You're going to your bank. You're identifying yourself with your password, and that connection is sniffed, either because it's just a plain HTTP connection, or if it's an SSL connection. Most of them are nowadays, but the OpenSSL library is shot through with so many holes and there's so many ways to sniff it that you're going to get compromised, and then you end up with a zero bank balance. HTTP is a security nightmare, and it's because of the complexity of managing state at the session or application level. Session level is layer 5. You got presentation at layer 6, and layer 7 is where you got applications. But it's all above TCP, and it should not be managed there. You got XSS attacks, you got HTML injection, you got SQL injection, and session hijacking. All because we're managing state at the wrong layer. The fix, okay, so the fix for all this was to come out with SSL version 1, which was so bad it wasn't even introduced. SSL version 2 came out in 1995, and its sole reason for being was being the reason that we needed SSL version 3 the next year. That lasted for a long time, but eventually we found out it was completely broken, and who knows how many years earlier the guys at 3-letter agencies had already broken it and were able to listen to everything that we were all doing. So we came out in TLS 1.0, but it could still downgrade to SSL version 3. And I got a super security guy here, so he's going to stop me if I say anything too blasphemous. Yeah. Hey, Jeff. So TLS 1.1 comes out 2006. It's got, but it's still got MD5 SHA-1 combinations, and MD5's got a whole host of problems. So they came out with TLS 1.2 in 2008, but you can still downgrade to SSL v3. And now they're currently working on TLS 1.3, which last time I checked had 14 major changes. And I just got to ask the question, was the 14th change the one that's going to make the internet secure now? Can we now use it for our banking transactions? And there's not going to be any 15th change coming down the pike, or TLS 1.4? No. This is not the way to do business. We got to blow the whole thing up and start with a bedrock foundation that is TCP. So yeah, there we go. I'm ripping off Jerry Maguire here, but yeah, we had the state at TCP. We didn't have to go all the way up the stack. We could have just kept that. And the thing about it was, in 1996, the web programmers had already fixed this. The 12 connection limit in the partial socket table, that was all fixed by 1996. But we never went back and redid HTTP like it was supposed to go, because I imagine it just too much of a head of steam, and getting everybody to jump off the track and get on a new train was going to be too much. So we left it like that, and now 20 years later, it's the internet is just it's like riding in a Jeep going through Mogadishu in the 1990s. You got tires burning on the side of the road. You got brigands with AK-47s waiting to rob you at a stoplight. You got people jumping on your car and taking all your stuff and jumping off. And plus, you got a guy in the back seat with a dark suit and sunglasses, typing on a laptop, writing down everything you say. It's just awful what we're having to deal with now, and it's very difficult to be able to manage state at the HTTP level. We've invented, a lot of smart guys have invented workarounds for all this, but just this week, what we got Google Docs getting hacked, or somebody trying to impersonate Google Docs. Apple had a big thing, and then Intel. We just found out this week that Intel is allowing backdoors for the last 7 years, ever since 2010. And the backdoor never even touches the operating system. It just goes straight to your hardware and sniffs everything, even your SSL stuff. So that's awesome. Okay. All right. So what's the real fix? Let me go back a slide here. The real fix, like I've been leading up to, is the Seif Project. Pronounced Seif, sponsored by Douglas Crockford. You might know about him because he wrote JavaScript, the good parts, and he works at PayPal. And PayPal is sponsoring this open source project, and they're not messing with him at all. They're just saying go do good things, and he's managing it like a true open source system. And for what I can tell, he's got two smart guys doing all the coding for him. He's a smart security guy, but he knows when he needs help, and they're not going to release this stuff until it's ready. And so the first time, the first YouTube video you'll find about it is from about November 2015, and the protocol for Seif just came out last month, April 11th. So they took their time getting the protocol right, and they built into the protocol a versioning scheme so that if version 0, which is that right now, gets if we find vulnerabilities, then they can just move up to version 1 and say, okay, that's the new way to do business. So what is Seif? Well, it's secure JSON over TCP. JSON is JavaScript object notation. It was popularized by Douglas Crockford. I'm not sure if you've met it, but he's the main man behind it now. And so it takes TCP as the bedrock and just passes messages back and forth using secure JSON. The handshake that the protocol uses is 1 round trip. Currently, HTTP requires at least 3 round trips, and if the web server doesn't know you, then it's going to take 4. And last I heard, they're not the speed of light is not going to get any faster. So the way to make web apps fast nowadays is to just not make as many round trips. So having a 1 round trip secure protocol is kind of the goose that laid the golden egg. All right, so it's also based on public-private keys between 2 parties. If you've ever been to a GPG party, you'll know that you have to generate your public and private key pair. And if you want somebody to send you a message, you have to give them your private key. It's the same thing here. You could call it PGP over TCP if you want. There's no certificate authorities or DNS in this that are needed in this new protocol. So that's interesting.
How are they publishing the public keys that can be trusted to say that I'm one of the parties?
We don't know yet.
With authority or DNS?
For everybody on the web, the question was, how are they trusting the other party? How do you know that the public key pointing to Chase Bank or Bank of America is actually Chase Bank or Bank of America?
It's less about how do you know that it's Chase Bank, but how does Chase Bank know that I'm their customer that is named so-and-so and such and such?
Right.
Because Chase Bank would be easy to do if you go to a trusted website and you know, the bank can have you
Yes.
install keys, but
Right. So the question was, how does Chase Bank know that that I am Ben Francis, and then that I'm really, authenticated or authenticated to go to this bank account and look at my bank balance and withdraw money and all that? And the answer is, I have to get my public key to Chase Bank some way through some secure method. And that is all part of the trust management system, which has not been written for the Seif protocol yet. But I have some guesses.
But it won't have any central
No,
certificate.
no.
Is it gonna
It
be
won't.
Bitcoin? Is it going to be blockchain?
Yes, I think so. I think it's going. The question was, is the trust management system for Seif going to be the blockchain technology that is used in Bitcoin? And I think absolutely yes. Douglas Crawford will not say one way or the other, but Bitcoin's been going huge for 7 years now, and still hasn't been broken. So that is a very likely candidate for as a secure replacement for DNS and certificate authorities. Last point here: both private keys are needed to hack the connection, that's pretty good. That's pretty good protocol if you got to have both private keys. All right, I know you can't see that. I just made this slide today. All right, so the difference between Web 2.0 or giving up all your private information for free email, and Web 3.0, which is secure apps over the internet, going side by side here. With Web 2.0, you got insecure apps over HTTP TLS. Web 3.2, we finally got secure web apps. Web 2.0, you got state implemented at level 7 insecurely. Web 3.0, you got state implemented at TCP level. At least 3 round trips are needed for 2. For Web 3.0, you only need a 1 round trip handshake. With Web 2.0, you got 37 passwords. Web 3.0, no passwords. You just got to keep that private key safe. Which
That's never going to be a problem.
we got giggles going on here, so obviously that could be a problem. But I kind of see that, like, you're probably going to have more than one private key. You're going to have one just for watching YouTube,
but that's a bit disingenuous then if you're saying that, we're going to get rid of passwords by making you have now, instead of 37 passwords, 37 passphrases that are going to go for 37
No, well,
keys to go to 37 different places.
no, I'm not saying. I'm saying 3, not 37. One for your super secret banking, one for your email, and one for your just get on the web and go without worrying about anything. That might happen.
Lose one of them, then it's all the nightmare to update everybody. Hey, I changed my identity.
Well, that could be too. Yeah, the question was, if you lose one of your private keys, then it's a pain to go and tell everybody.
And why would you believe someone?
Yeah. Okay. So lots of things to consider. Web 2.0, you have DNS. In Web 3.0, you've got Safe Trust Management, and we're speculating that it's the blockchain. In Web 2.0, you have certificate authorities like VeriSign and CNNIC. Does anybody know what CNNIC is, by the way? If you go into Firefox and you look at your all the trusted certificate authorities in your that Firefox trusts as certificate authorities, one of them you will see is CNNIC, which is Chinese telecom. And I don't know when I was using Firefox in the military, that was a big surprise to me. What? Why are we trusting those guys?
It's been a running joke on security now because the Hong Kong post office has a trusted SSL cert that was in every browser for over a decade.
There you go. There you go. So we got to have something better than this. Third party certificate authorities just ain't cutting it. All right.
Ben, I have a question.
Oh yeah.
What do you mean by Web 2.0 has DNS? What's the what
Well,
do you mean by
Web 2.0 relies on DNS and certificate authorities, and Douglas's protocol does not need that. It can still use it, but if you go into safe mode in a browser, you can't do it yet, but you will be able to. Safe mode is going to just kill the whole HTTP stack and start from TCP on up and say, okay, everybody off the court. You know, I'm in charge now, and we ain't doing anything like that. But obviously the DNS and the certificate authorities, those that trust management function has to be replaced by something, and I think it's going to be the blockchain.
Okay, so websites will still need DNS. If I want to go to www.google.com, I'll still have to have DNS to resolve that, but just not use it for my certificate.
Yeah, well, this is how I kind of this is how Douglas explains it. If you go to your bank and you set up an account, they're going to give you a business card with a QR code on it, and then all you have to do is scan that. I know we're scanning QR codes with Android phones is probably not secure, but there's got to be some way to get that QR code to resolve to the bank's public key securely, so that you can go and do business on the web with that bank.
I would assume basically within the blockchain, you're probably going to have those DNS records moved from a traditional DNS server to part of the blockchain itself.
Yeah, there you go.
So you've probably got the IP addresses and the names of their secured servers. And when you do a lookup based on the public key, you'll get that information. But that's just a speculation as to where they might move it.
Okay, did you all hear that?
Yes.
Yeah.
Okay, all right. And I won't belabor the point. This is Douglas Crockford, Mr. Jason from PayPal. I would highly recommend watching one of his YouTube presentations on this. His short one goes 16 minutes, and the long ones go about 42 minutes. And I like the long ones because they get down and dirty. And anyway, what's most impressive about the technology about Doug's plan is that he's going to do it securely. He's not going to rush it. He hasn't rushed it. Safe Node and Seif Protocol have just been released, and he's still got three more parts to do. You got resource management, which we've been talking about here. How are you going to do the DNS and certificate authorities and all that? How do you know websites and people are really the people you're talking to? He talks about safe apps. So if you're going to throw away HTTP, how are you going to display stuff on your screen again? And he wants to do it with a package called Qt or Qt. It's a software package that originated in Europe, and he says not a lot of Americans know about it, but I've heard about it a lot as a developer. So it's not entirely unknown here in America, but they're going to strip out the parts of Qt that are not secure, and they're also going to strip out the parts of Node.js that is not secure either. For example, Node.js will comes bundled with the npm package manager, and basically the npm package manager will trust anything from anybody, anytime, anywhere. And that's a bad model. That's a bad package to have in a security suite. So they're going to junk that and a bunch of other stuff, and they're just going to use the stuff that the Seif project needs to make sure the application is secure. The Seif Helper app in the browser is going to be Douglas's way to get Seif installed into a browser so that it doesn't break the entire web. It's just, if you go to a Seif website, it'll switch to that mode and say, give you a big green lock icon on the screen that says, okay, this is a super secure site, and you're cooking with gas. I need to mention, I kind of gloss over Safe Node, point 1 right there, but that's the key part of this, because it's got 4 cryptographic protocols embedded into it. They're taking randomness and entropy seriously by using AES 256, ECC 521 for the public and private keys, and SHA-3 256. And also the way they're getting randomness is they are not only collecting randomness from the operating system, which in Linux case would be devu random, but they're also going to add in some randomness from your microphone and your screen. And he says they're only going to take a couple seconds of microphone and a couple seconds of screen to make everything random. So he's not trusting the operating system's randomness to give you to do all the cryptographic stuff that they're doing in Safe Node. All right. Why did this take 20 years? Okay, so a bunch of companies knew this while the web was getting going, and they said, well, we can do this better than a stateless protocol, so let's do our own thing and try to capture the web. Microsoft tried this, Oracle, Apache, Adobe. They all made better web apps, but so the technology was better, but they tried to capture the web and make it all proprietary, and so it didn't work. No open standards, and they didn't have a transition plan. And what characterizes Crockford's plan is that he's got a good transition plan, whereas all the others failed. This slide's probably going to take a while to load, but it's a slide of the Wright brothers. If you have a chance, go ahead and get the CD or the book that was recently written about the Wright brothers. It is an amazing testament to the persistence of these two guys, who are not, highly educated or anything like that. They just had a ridiculous vision to succeed where everybody else before them failed. So I got to ask, this is that point in history where you can say, everybody else failed before this open source project. This one can succeed just the same way these guys did. So here's Douglas's transition plan, and I took this straight from his site. Watch his presentation; it's much better than mine. But his plan is to get Safe into one browser. Could be Firefox, Chromium, maybe even an old browser like Lynx. I think it would be funny if Lynx got it first. Just they have the most advanced browser, be the oldest one. And one super secure site, like I don't know, a Swiss bank or maybe the DoD, or somebody that really needs to be secure. This would be the way to do it. And if you're looking to make a ton of money, I mean, the guy that can fork Firefox and tear out all the HTTP and implement Safe the safe handshake and the safe protocol, he's going to make a ton of money out of this thing. I have no doubt. This protocol will create companies. So you get it in one browser, one secure site, and after people start doing business with that secure site, all the other browsers and all the other sites are going to be like, oh, wait a minute, we've just been one-upped, and risk mitigation is going to compel those other sites to just follow. And the way Douglas describes it is when penguins go into the water, they don't just go to the edge of the water and jump in. There's a whole bunch of penguins get right up to the edge, and they're all looking down, and they're all squishing forward, and they don't want to jump into the water because there's things that want to eat them down there. There's fish, there's fish and all kinds of goodies, but there's seals and sharks, and so what actually happens is the weight of the penguins pushing forward actually causes one of them to get pushed in, and then everybody looks down and says, did he get eaten? If he comes back up, then everybody knows it's safe to jump in water, and they all go. So that's what it's going to be like with this protocol in this software.
Hey, Ben.
Yeah.
Is it possible that the super secure site might be PayPal?
Perhaps.
Yeah, I haven't thought of everything here. But that would make a heck of a lot of sense, yeah. PayPal using blockchain technology would be a huge competitor to. It would be the anti-drug dealer way to move money, because Bitcoin is kind of associated with the nefarious types that want to move money without anybody knowing about it. So yeah, thank you, Jace. That's a good point. The world's gonna let's see. Point 4, competitive pressure will move the other browser makers to support safe, and the world's going to follow to be secure and for faster application development. I talked to a developer just yesterday and asked him how much time that he spent managing state on his applications, and he said it's at least 30% for every new project that he starts. So that's a good thing. And best of all, nothing breaks. You're still going to be able to go to the entire World Wide Web that's out there right now. It's just that when you operate in safe mode, you're going to be super secret just between you and the party that you're browsing to. One thing that Doug is trying to settle is, what do you replace HTTP with? His first instinct is go with safe, probably just because it's a unique name and nobody's going to confuse it with anything. But why not go with web? I mean, and he asked this in his own presentation too. They had a chance to do this with the first web, 25 years ago, and they went with HTTP because it was developed by a technical person, and they like to refer to protocols and not simple names.
Ben,
was there a question?
Ben, you're frozen. Your screen is frozen. No, never mind. There it is.
Okay. All right. So yeah, should we go with safe or web? I would like to go with just web : and then what would follow that is the public key of the person you're trying to connect to. Of course, it's not anything you could ever remember. So Douglas says we're going to have pet names to, a pet name like Chase to refer to, Chase Bank. And that kind of sounds like DNS, but that pet name is your pet name. It's not everybody's pet name. So it would have to be locked in a secure place that is only accessible by you. Could be on the cloud in a safe place, but that's kind of a oxymoron. I don't know how they're going to do that. But so trust management is still up in the air. All right, so this is 1991 again. Imagine that you are Tim Berners-Lee's friend, and you went out to lunch one day and you said, "Hey Tim, what's happening? What's up?" And he says, "Well, I'm kind of working on this World Wide Web thing where you can share documents no matter what kind of machine you're currently working on. And if you were smart enough to to realize that that was what was absolutely needed at the time, what would you do? I mean, if you got it and you decided that, hey, yeah, I want to be on that train, what would you do? Would you? I mean, it's a world of possibilities, but I'm saying this is your chance in 2017 to be on the next web. And what do you do now? If you can see that slide. Well, you definitely have to retrain and adjust your thinking for anything for the new Seif world. You could start a company. You could start a Seif project inside your current organization. The world's your oyster, really. So there's no telling how this could go, and it could fizzle too. I've been wrong before, but I haven't seen anything as good as this since the web came out 25 years ago. Marketing. This is just kind of a note to myself of how this thing could expand, just like the regular web did when it came out. And the last slide I gotta mention is don't quit your day job, because Seif is still vaporware, and Douglas freely admits this. Only 2 components are done: the Seif node and protocol. They're both on GitHub. You can go check them out and submit pull requests if you find bugs or whatever. The trust management is not clear. We don't know if blockchain is going to replace DNS. So there's a lot of questions still up in the air. And so it's best to tread lightly, but yeah, I would be thinking about where everybody could go from here. So that is Web 3.0, and I'll throw up some references and take some questions. Okay, so anybody in the upstate got a question about the Seif protocol and Web 3.0?
I just asked around. I think we are all questionless.
Okay. There's one reference on the slide there that doesn't seem like it's like I got the whole thing there. It's from Aaron Schwartz. Before he died, he actually wrote a blog post called "Squaring Zuko's Triangle," and it's a really neat piece about a conjecture called Zuko's Triangle that states that a name can be only 2 of 3 things. It can be secure, it can be globally distributed, and it can be human meaningful. And you can only the conjecture is that you can only have 2 of those things. And when DNS was first designed, it picked human meaningful as the most important thing. But Douglas goes the other way and says, no, I'm much more interested in being globally distributed with no central authority and secure. And that's why he designed the protocol not to rely on DNS. But Aaron found a way to square Zuko's triangle and provide all 3 items in one in one go. And so I would recommend going to Aaron Schwartz's weblog and just search for "Squaring Zuko's Triangle." You'll go to it immediately, and it's a great read. He talks about imagining a scroll where the scroll is shared between everybody, and everybody can add lines to the scroll, but nobody can delete lines, so that everybody has to agree on the line that gets added to the scroll, and so therefore the only way that you could hack it was to create a duplicate scroll and get more than half of the people out there to verify the fraudulent scroll. So that's a great rule. That's a great read, and I recommend everybody see it or read it. Also, take a look at Douglas's presentation at O'Reilly.com. That's the 16-minute deal, and definitely go see Marcus Raynham's Internet Nails Talk. All right. Any questions here in Columbia? UC log, Charleston, CSE log. No. Okay.
I guess this will be really helpful for like IPv6.
Oh yeah. Okay. So the question was, this would this be helpful for? Well, it was a statement saying this would be helpful for IPv6, and that's a good point. I see the main blocking technology for or the main thing that's blocking IPv6, even though it's been around for 15 years, is the doggone names for IPv6 are so long that nobody really wants to deal with it. Even with the shortening things that you can do with it,